Now we will learn the properties in number system. We have different properties in number system. They are closure, commutative, associative, existence of identity, and existence of inverse. We will verify whether rational numbers satisfy these properties with respect to four fundamental operations. Properties of rational numbers. We will verify whether rational numbers satisfy closure property with respect to four fundamental operations: addition, subtraction, multiplication, and division. Now, let us take A and B, two rational numbers. Then the sum of the two numbers is again a rational number. The rational number satisfy closure property. And if the difference of two rational numbers is rational, it satisfies closure property. And if the product of two rational numbers is rational, then it satisfies closure. And if the quotient of two rational numbers is rational number, then rational numbers satisfy closure property with respect to division. Now we will take few numerical examples whether satisfy closure property or not. Now first let us take here 1 by 2, 2 by 5. These two are rational numbers. If we add these two numbers, the result is whether rational or not, we have to verify. 1 by 2 plus 2 by 5. LCM of 2 and 5 is 10. Now, how many times of 2 is 10? 5 times. 5 1 ja 5 plus how many times of 5 is 10? 2 times. 2 into 2, 4. Now, 9 by 10, which is a rational number. So, rational numbers satisfy closure property with respect to addition. Now, with respect to subtraction, take 1 by 2, 2 by 5, which are rational numbers. Now, if we see the difference, 1 by 2 minus 2 by 5. LCM is 10. Now 2 5 are 10. So 5 into 1, 5 minus how many times of 5 is 10? 2 times. Now 2 into 2, 4. That is 1 by 10, which is rational number. So we can conclude that rational numbers satisfy closure property with respect to subtraction. Now the third one. That means we will check with respect to multiplication. Now 1 by 2 into 2 by 5. Here numerator and denominator both are same. So we can cancel one time. Now the result is 1 by 5, which is a rational number. So rational numbers are closed under multiplication. Now we will check the fourth one, division. So if you see the division, if any number divided by 0 is not defined. For example, if you take 3, 0 belongs to Q. 3 divided by 0 equal to 3 by 0, which is not a rational number. So we can conclude that rational numbers are not closed under division. Now we will see next property. Commutative property. Commutative property states that the change in the order of two numbers on binary operation does not change the result. Here the binary operation could be any of the one of the four fundamental operations. That means maybe plus, minus, into, division. Now, if you take two rational numbers a and b, two rational numbers a and b, now the sum of a and b will give you the same result as sum of b and a. So if you change the order, the result is same. In multiplication also, we will get the same result. Whereas in subtraction and division, LHS and RHS, we will get different values. So we can conclude that rational numbers satisfy commutative property with respect to addition and multiplication only. So we will take numerical examples. Now, here take 1 by 2, 2 by 5, which are rational numbers. Now 1 by 2 plus 2 by 5 is, now the LCM is 10. 2 times of 5 is 10. So 5 1 ja 5. 5 times of 2 is 10. Means how many times of 5 is 10? 2 times. So 2 into 2, 4, which is 9 by 10. Now we will change the order. So 2 by 5 plus 1 by 2. Now the LCM is same. We will get in the beginning 4 and next we will get 5, which is 9 by 10. So we got LHS and RHS, both are same. From this we can say that rational numbers satisfy commutative property with respect to addition. Now we will check in multiplication. Now 1 by 2 into 2 by 5, that equal to, here you can cancel 2 and 2, numerator 2 and denominator 2. We will get 1 by 5. The same way, if we change the order, 2 by 5 into 1 by 2. Now numerator 2 and denominator 2 we can cancel. The result is 1 by 5. LHS equal to RHS. So rational numbers satisfy commutative property with respect to multiplication. Now we will verify whether rational numbers satisfy commutative with respect to subtraction. For example, if you take 3 and 7, which are rational number. Now 3 minus 7 is minus 4, whereas 7 minus 3 is 4. If you observe this, LHS is not equal to RHS. From this, we can conclude that rational numbers won't satisfy commutative property with respect to subtraction. The same way, the fraction, for example, 3 by 7 and 7 by 3, these two are not same. So we can conclude rational numbers won't satisfy commutative property with respect to division. Now we'll do associative property. Associative property states that if you have to add three numbers, you can add first two numbers, then third number. Or if you add second and third numbers first, then you add first number, the result is same. Here we are taking A, B, C, three rational numbers. First two rationals A and B, the sum of A and B, if you add to third number C, the result is same as if you add second and third rational numbers and add to first number, we will get the same result. Then we can say that numbers satisfy associative property. In the same way, we will check in multiplication also. So let us take numerical example. So 1 by 2, 2 by 3, 3 by 5. Now, first two rational numbers we will add. 1 by 2 plus 2 by 3 plus 3 by 5. Now here 2, 3, LCM is 6. How many times of 2 is 6? 3 times. So 3 plus how many times of 3 is 6? 2 times. So 2 2 ja 4 plus 3 by 5. Now 7 by 6 plus 3 by 5. Here the LCM of 6 and 5 is 30. How many times of 6 is 30? 5 times. Now 5 into 7, 35. Plus how many times of 5 is 30? 6 times. 6 3 ja 18. Now 35 plus 18, 53 by 30. Now we will see the RHS part. That means 1 by 2 plus 2 by 3 plus 3 by 5. Now first we will do the sum in bracket. 3 5 LCM is 15. How many times of 3 is 15? 5 times. Now 5 2 ja 10 plus how many times of 5 is 15? 3 times. So 3 3 ja 9. Now 1 by 2 plus 19 by 15. The LCM of 2 and 15 is 30. Now 2 into 15 will give you 30. So 15 1 ja 15 plus 15 into 2 is 30. So 2 19 ja 38. Now 15 plus 38 is 53 by 30. So LHS and RHS both we are getting the same result. That is why we can conclude that rational numbers satisfy associative property with respect to addition. In the same way, you can do in multiplication also. There also you can get LHS and RHS parts, both are same. Whereas in subtraction and division, associative property won't satisfies. Now, the fourth one, existence of identity. If you add any number to 0, we will get the same result. For example, 2 by 3 plus 0 will give you 2 by 3, or 0 plus 2 by 3 is 2 by 3. So what is existence of identity is, if you add 0 to any number, we will get the given number only. That is the here, then we can say that 0 is the identity element in addition. If you take here, a is a rational number. So a plus what will give you a? Here obviously we should write 0. A plus 0 equal to a, and 0 plus a is also a. That is why we can say this 0 is the identity element with respect to addition. Here we are adding. So by what number you are adding? With 0. That is why 0 is the additive identity. And now multiplication. In multiplication, what is the identity element? We have to identify. Now, if any number is multiplied by 1, the result is the given number only. If you see here, a into how much will give you a, same result. So here we should write 1, and here also we should write 1. A into 1 and 1 into a, both will give you a. So in multiplication, 1 is the identity element. So for any numbers in any means, in natural numbers or whole numbers or anything, here additive identity is 0 and multiplicative identity is 1. Now in natural numbers, is additive identity exists? Can anyone say? So no, 0 is not existed in natural number. That is why in natural number, additive identity does not exist. Now we'll see the last property, existence of inverse. Now here observe that 0 is the additive identity and 1 is the multiplicative identity. Now existence of inverse. What is inverse? Inverse means if the sum of two numbers is an additive identity, then the two numbers are additive inverses of each other. That means if a plus how much will give you 0? Here obviously a plus minus a is 0 and minus a plus a equal to 0. Here 0 is additive identity. The result of a plus minus a is 0. That means a is the additive inverse of minus a is the additive inverse of a. Now in multiplication, the product of what two numbers will give you 1. So if you take 2 by 3, 2 by 3 into what number we have to multiply to get 1? 2 by 3 into 3 by 2. Then only we can cancel numerator and denominator. Here numerator and denominator, the answer is 1. If you take 5, 5 into how much will give you 1? We know that 5 means 5 by 1. So if you write 5, here we should write 1 by 1. Now 5 gets cancelled. The result is 1. So here tell me a into what we have to write here to get 1. Here 1 by a. Then only you can cancel a and a. The result is 1. Or here also 1 by a. A gets cancelled. The result is 1. So here multiplicative inverse is also called as reciprocal. Reciprocal and multiplicative inverse both are same. Now here the last one, distributivity of multiplication over addition. So if you observe here, we are distributing multiplication symbol to addition. What is the distribution? Distribution means to give. Here the outside value is a. We are distributing a to b and a to c. So a into b plus a into c. That is distributive property of multiplication over addition. Here a is left side of the bracket. That's why we can call it as left distributive property. If the distributive element is right side of the bracket, then we can say right distributive property. In the bracket, how many numbers are not important? Whatever may be the numbers, just we have to distribute the outside element to inside. So here this is distributive of multiplication over addition. And if you see the distributive of multiplication over subtraction, so a into b minus c is there, we can say that a into b minus a into c. In this way, we can distribute multiplication over subtraction also. So this is about 6 properties in number system. So we verified the properties in rational numbers. In the same way, we can verify these properties in the subsets of rational numbers. So integers, whole numbers, natural numbers, these are all subsets of integers, rational numbers. So we can verify these properties under 4 fundamental operations.